Welcome to Real Civil YouTube channel. In this very important, very interesting video on pushover analysis, I am going to explain you how to find the performance point in pushover analysis because that is the very important point to check the performance of the building is safe or not. Pushover curve is not the end, it's the beginning of our analysis. So I have made one video already in which I have shown step by step how to analyze this case pushover. Okay, so you can check that link in the description box, or you can click on the I button also. In this video is specifically for how to determine the performance point in pushover analysis. So the definition is very clear. The performance point means how much our structure is displaced during the future earthquake. Based on that displacement, we will check our structure is safe or not, or it is required some retrofitting or seismic retrofitting. So let's see how can we find that point. Okay, to find that point, we need to define the response spectra. So you can go to functions, response spectrum. Here, select the code uh, of your country. You can click on add new function. Here I will give the name Indian response spectra, and I will fill the details. Okay, you can put the details of your building, your site, and just click on OK. Click on OK. Now we have to go and create a load case related to the response spectra. So I will show only for X direction. You can replicate for Y direction also. Okay. So response spectra in X direction. Select response spectrum. Add here acceleration U1. Here you have to select the function that you have defined. IS, RS I have defined. Then click on OK. Click on OK. Similarly, you can go for RX response spectrum in Y direction, but for time being, I will show you only X direction case. Now go to Analyze, set load cases to run. I will run the required cases only here. First of all, response spectrum in X direction, and then EQ X. Okay, we have to check the base shear in EQX as well as in response spectrum X. As per the code, the base shear of response spectrum case should be at least the base shear given by EQX, that is linear static. If not, we have to multiply. So to check that, go to display, show tables. Here we'll select the required case, click on OK. Now you can see here the base shear in X direction EQX is 906.4004, and the base shear response spectrum is 366.155. That means it is less. So we have to make the base shear of response spectrum case at least equal to EQX. So 906.4004 divided by 366.155. So this factor is 2.48. We'll consider 2.48. Okay. So go back to define load case, response spectrum, modify. Here we have to change the scale factor by 2.48. Click on OK. Click on OK. Now we'll again run the case. Now we will see the base shear. So go to display, show tables, click on OK. Now here you can see we have almost matched the EQX and RSPX. If it is more, it is okay. If not, then you have to do this procedure. Okay, done. Now we will run our push X case. So go to analyze, set load cases to run. I will show you only push X case. You can similarly do for push Y also. Analyze, set load case to run, push X. Now we'll wait until this push X case. It takes time for pushover analysis because it performs multiple linear static procedures one by one. So you can watch our previous video on pushover analysis, first part, in which I have explained the detailed procedure. In second video, I have explained you about the pushover curve, the results obtained. Then third part was the theoretical information about the pushover analysis. So what things you can get from the pushover curve, like maximum base shear, maximum displacement, then suppose there are any inherent weaknesses, then you can study. I have given the examples of that also. And this is our fourth video where I am explaining you about the performance point. Yes, the procedure is complete. Now first of all we'll see the static pushover curve. Here you can see the curve in X, push X curve. Now this is the entire journey of the structure, right from no displacement or zero load until some value of the load. So this is the entire journey. Some part is linear, then structure is going into non-linear phase. Okay, but we are interested in finding the that point, that target displacement, that performance point. Okay, there are two methods basically: improved capacity spectrum method and also displacement spectrum method is also there. Okay, so first one is the FEMA 440 equivalent linearization. So using this method, you can also find this push X, that performance point. So for that, here in the demand spectrum, you have to select your own. That is a defined function, and I have defined the ISRS. Then it is asking for shear. It is asking for a scale factor, which we have given in the response spectrum case. So we have to copy that. We have to copy this scale factor, and you have to put this scale factor here, and then you can see the performance point is given. It says point is found, the base shear 1012.7, and the displacement is 28.51 mm. That means in future earthquake our structure will get pushed to that limit. Okay, and there are some other things are also given. So what you have to do, you have to go to just remember this 28.51. Okay, so you have to go to pushover curve, go to, yes, you can see that 25, 28. So we will consider this 40. So if you see, if the displacement is 40.644, that means performance point is at 28 mm. So we'll go for a safer side, 40.644. Then these are n- number of hinges form. Okay, so you can see how many hinges are formed. So basically 14 hinges form. So you can go to display, deformed shape, push X, and you can select any one of the pattern, and then you can go stepwise. That means not much things or damage is there as per the future earthquake considered, because we have selected the zone 2, maybe because of that it is less. But in case if you have some more displacement as a performance point, then you can see some collapse prevention, some hinges are getting formed. So it shows that this column may get fail. Okay, so you have to work out here what retrofitting or what strengthening techniques can be used. Okay, so as per my case, it is safe for step number 3. But if it is more, then I have to do something there. Okay, so this is one way. Then next is you can also get it from ASCE 4130 NSP, Nonlinear Static Procedure. Again, here you have to select the your spectrum, define function, ISRS. Again, you have to paste the value here. Again, it is showing a displacement 28.563 and base shear. So it is almost up to that displacement. Our structure will get displaced in future earthquake. As it is in zone 2, maybe because of that the it is showing less displacement. As zones are go increased, the displacement will increase. And then you can also include the soil structure in interaction. Then these values you can get in the code, like these ranges from 1 to 1.5. Okay, so if you change it as per the structure, your base shear, your target displacement will change. Okay, so this is the target displacement. That means my in future earthquake, my structure may get displaced up to 42.396 mm. So I have to check the performance at 42.396 mm. So you can go here, you can use any one of the method. So 42, that means close to 40, or if you refer for saper size 55.61, then these many numbers of hinges are getting formed. Or you can see some of the hinges are in collapse prevention. That means you have to work out here. Okay, because some of your members are directly going into collapse prevention case rather into life safety or life safety to collapse prevention. So that means the section sizes that you have selected, maybe some members are getting overstressed, or they may get immediately into collapse prevention. So this is how you can use the pushover analysis, the concept of performance point. Now yes, you have to work out, you have to do some strengthening techniques if it is existing building. So this is how you can use this pushover analysis. I hope your doubts are clear. If you have any problem in analysis modeling, you can ask me in the comment box, or you can contact me on the social media. The platforms links are given in the description box. Thank you so much. Please like, share, subscribe the channel. Thank you so much.